Hi, hello everyone. Today I'm going to show our latest gas sensor for acetone detection, especially for the fat burning effect monitoring. So my name is Tomohiro Kawaguchi from Figaro Engineering, Japan. So before starting my presentation, please let me introduce our company a little bit. So our company name is Figaro Engineering. We are based on Osaka, Japan. So our company was established 1696. So this year, 2024, is our 55 years anniversary. So what our company doing here is, of course, about gas sensor. So that is R&D and the manufacturing and sales and marketing about gas sensor. So our current production capacity is roughly 3 million pieces per month. Actually, last year, 2023, we shipped over 20 million pieces gas sensor to the world. Especially our current main big market is the US. Okay, so currently, so the 70% of Figaro sensor is manufactured in China, Tianjin, China. And we also have a factory also in Japan. So, and not only factory, but also we have sales branch in US and China. And also from a couple of years ago, we had a European office in Neuss. It's near the Düsseldorf in Germany. So here's our history. So we started our business from, as I say, 1969 with a MOS type sensor. So at the time, the MOS type sensor was very big, so that consumed a lot of power consumption. But after that, we started trying to make small to our sensor so that the power consumption of sensor is reduced. And not only MOS type sensor, but also we are now producing a lot of the chemical sensor and catalytic type sensor and optical sensor as well. So that's why we are still growing up. But our main big concern is our major business has not been changed over the last 20 years. So our main business is for the safety gas sensor for safety application like explosion gas alarm or carbon monoxide gas alarm, and sometimes we supply the sensor to air quality application. But this type of major business has not been changed over the last 20 years, so that we now need to look for something new. So this presentation, detection for acetone, is kind of new challenges of our company Figaro. So, okay, so let me start my presentation. So I'm showing the one smart dog in the picture. Do you know this picture? So this picture comes from UK, and he must be very smart dogs. So what he's smelling is he's smelling some exhaled breath of the human. So these smart dogs can distinguish the breath from the patient of COVID-19 and the healthy people, right? So I'm not sure the exact accuracy rate of this smart dog, but what I want to say here is the patient suffering from diseases has a unique biogas. So biogas means the gas generated from in the breath and the surface of skin, sometimes urine. So yes, that is maybe the potential business for like our gas sensor manufacturer. So this is one of list of the biomarkers gas. Biomarker means main components of biogas. Okay, so as you can see, the major biomarkers is acetone. Oh, sorry. Yes, like here. So these acetone sometimes generated from the people has diabetes, and sometimes the people with obesity. So yes, so the obesity people generally generate acetone in their breath, but when such people has the exercise and sometimes the ketogenic diet, in that case, the acetone concentration in their breath is increasing. Okay, so not only acetone, but also sometimes the methane and pentane and carbon monoxide, ammonia and nitric oxide is generated from their breath, depending on diseases of the internal diseases. So the key point in this page is that in most cases the target concentration is very low. It's always the 1 ppm or less than 1 ppm. So the sensor, if we would like to detect these gases by sensor, in that case the sensor needs to be high sensitivity. Okay, so at this moment there is several measurement methods for this kind of the low concentration of biomarkers. So one major analyzer would be the gas chromatography mass spectrometer, and maybe the FTIR as well. So this type of analyzer is best measurement method if the people want to have good accuracy. But this type of analyzer has a big dimensions, and also the price is very high, and sometimes for measurement it is required for professional skill. Okay, but in contrast, the more simple method like using single gas sensor or sometimes ENOs as well, that is very simple, and it's a very low cost solution, and sometimes doesn't need any professional skill. So we believe so this kind of the analyzer is good for the, for instance, hospital or clinics, and maybe this kind of simple solution is good for the portable device. That's what we are now thinking. So, so when we measure this kind of the biomarkers gas, in that case, there is a lot of benefit if people use the single gas sensor. So one is non-invasive. That is, people doesn't need to cut finger and doesn't need to pick up any blood. So just blow the breath to the machine. That is, and also it's non-hazardous. That means the sensor doesn't require any high voltage and no X-ray. So it's very safety. And also, as I say, the sensor is a very low-cost solution. And if the sensor has sufficient sensitivity, it can be used for the real-time monitoring. And the key point in this page is this kind of device may be used for the disease state monitoring. That means if, how do I say, the portable device with single gas sensor is very compact and very low cost, people easy to buy it, and people possible to make a measurement in every day. So, so if we can accumulate the test data day by day, then we can see the trend of the how our body condition changing. So that's gonna be good information for the hospital or judgment of diseases. But in other side, so there is some challenges for such single sensor for usage such low concentration of measurement. So one is, as I say, the target gas concentration is very low, so the sensor needs to be very high sensitive. And also, in our breath, sometimes includes ethanol or hydrogen. Or maybe today, after a few hours later, people start to drink. Then in their breath, lot of alcohol is contained. So sensor don't need to be affected by such interference gas like ethanol or hydrogen. And of course, if the sensor put in a portable device, in that case, the sensor can be operatable without any maintenance. So that the sensor should have the longer life. And also our breath includes some moisture. So sensor should not be affected by the moisture. And also for portable device, the sensor needs to be small, right? So this is our solution. So we developed a new sensor, TGS1820, that is for the acetone detection, especially for the fat burning effect monitoring. So we believe this sensor can solve some challenges, as I say in the last page. So the sensor is very high sensitivity and low cross sensitivity and long life and the low humidity impact and very compact size. So this is the appearance of the sensor and the internal structure of this sensor. So as you can see, the sensor is very small. It's not like a MEMS sensor, but it's still small. The height is 12 millimeter and 6 millimeter diameter, so it's very compact. And this is the internal structure of sensor. So there is one heater coil, and the sensing material is covered with the heater coil. So this structure is very unique because in the general type MOS sensor has a different circuit of the sensing material and the heating material, but in this sensor it's combined. So in the measurement circuit, the combined register of the heater coil and the sensor material was measured as the signal output and then converted to the concentration ppm. So now we say this type of structure as a hot wire type structure. Okay, so this is the operating circuit and condition. So this sensor can be operated in this kind of very general Houston bridge circuit. So the customer just putting the fixed voltage to the sensor circuit, and then they can get the signal output from the sensor. Okay, so the standard operating condition of this sensor is just applying the constant voltage. So in that case, of course, we can have very stable signal output, but sometimes the response speed and selectivity to acetone is not good enough. So now we are thinking the different operating condition like this way. So the special operating condition is high and low operating. So when the sensor put in the portable device, when the people push start button, the sensor heated the little bit higher temperature for 30 seconds. After that, we applying the little bit lower voltage to the sensor for 20 seconds. In this time period, the people can exhale their breath. So after the sensor exposed to such breath, the sensor signal is getting increased. So the reached level will be depends on the concentration of acetone, so that we can convert this sensor signal level to the acetone concentration, the ppm level. That is the principle of this sensor. And this is the sensitivity characteristics of this sensor. So for your information, we also showing our conventional type MOS type sensor TGS2602. We used this sensor for the acetone monitoring application. So the x-axis is gas concentration, the y-axis is the sensitivity level. So you can see that this blue line is showing the sensitivity level to acetone. So, and as you can see, both sensors has a very similar and good sensitivity to acetone. So clear response over 1 ppm acetone, and also the sensor shows the potentially sensor can detect the less than 1 ppm concentration as well. So also both sensors has very low sensitivity to hydrogen, that is interference gases, and them. So but the sensitivity to ethanol is a little bit different. So our conventional type sensor also can sense ethanol, but this new sensor not affected by ethanol. So now we believe this new sensor has a lot of potential rather than our conventional type sensor. So we now doing some laboratory tests with this new sensor. So this is one of long-term test of this sensor. So we have been continuing the several kind of long-term stability test. So this is one. So usually the sensor put in a normal condition. It's like a normal room. And sometimes the sensor picked up and the sensor put in a chamber and we check the sensitivity sometimes. So as you can see, even such condition, the sensor sensitivity to acetone or sensitivity to hydrogen ethanol is always stable over 180 days. And this is a little bit more realistic data. So the sensor always exposed to the synthetic human breath. It means the air with high temperature and high humidity. So in that case, even if the sensor was exposed to 7,000 times to such synthetic human breath, the sensor sensitivity always stable. And so this is one of long-term test. So this is more realistic. So my colleagues blow his breath to the sensor one time in a day. So he continued to blowing his breath over 500 days. So the sensor, acetone, the sensitivity, and any other sensitivity is still stable. I don't know why this is one irregular point here, but maybe that is kind of the handling issue. So we believe the sensor still is stable. Okay. So with this data, we are now making the concept model of the breath acetone monitor. The dimension is like this, and it's very small, and people easily to blow their breath by using the tip of straw. So we believe it's easy to carry inside the handbag, sometimes the business bag, and people can measure their breath everywhere they want. And this is our internal structure of this monitor. So the circuit is very simple, not complicated, but we are focused to develop the very unique internal structure. You see something like here, because in our breath, sometimes includes some liquid stipple. So we need to trap the liquid drop by using the internal structure. And also if someone make a very strong blow, sometimes the sensor affected by the blow. So in this monitor, so we can make separate flow. One is for the exhaust to outside. The only some part of the breath can come to the sensor place. Yeah, something like that. Okay. Yes, so we are just gas sensor manufacturer, so we are not professional about medical or healthcare applications. So now we are looking for the potential partner who can evaluate this kind of the product and sensor. So now, we are prepared some kind of the data sheet about the single sensor. Also, we have some evaluation module for this sensor, and we are also preparing the application note. So in this application note, you can see what is a high operating mode and what is the signal processing, and you can see any other test data internally obtained in Figaro. Okay. So yes, so if you have any interest to this sensor, please contact us. We are always waiting for your inquiry. Yep. Thank you very much. So any question? Thank you. Thank you. So we have a booth in our oversight. I'm not exactly sure the number of the booths, but maybe you can find. 5, 5, 561. Okay. So my call is waiting for you. Okay, thank you very much.